AC and DC. So we know what is AC and DC. That's AC is a alternate current and DC is a direct current. So what is alternate current and what is direct current? In the case of alternate current, there you can see in the graph in the slide. So AC is represented in the case of waveform, and below that DC is represented as a straight line. So in case of AC, in with respect to the time, that is the x-axis, the y-axis value, that is a voltage or current value, will it is changing, it is alternating, that is positive. So for certain time period that will be in a positive, and certain time period it is going for the negative. So alternatively it is changing with respect to the time period. So that's why we are calling it as an alternate current, because there is an alteration, there is an alternative, positive negative, positive negative, likewise the waveform look like. So that's why it is called as an alternate current. So the but in case of DC, it is a direct current, there won't be any fluctuation, there is no alteration, positive negative. So it is a straight line. In case of, you see the graph, you can see the straight line. So that's why it's called as a direct current. So it is direct current will be flow in the only one direction, but in case of alternate current, it will be flowing in the both directions. So that is a difference between the AC and DC. So what's the purpose of studying this AC and DC is nothing but of, in some places, in some of the circuits, we use alternate current, and some of the applications we are using direct current, that we will see in the forthcoming videos, right, clearly. So, but this is the difference between AC and DC. Okay. So this is the type is determined by only the direction of the current. So if the direction of the current is in both sides, that means a alternate current. It is in only one direction, means it is a direct current. And next to that is Ampere's law. So this Ampere's law is most important one, because there is a concept behind this Ampere's law you have to understand. That is, if you keep your right hand thumb like this, right, so there is a thumb, so from the thumb you have a straight line. You just assume there is a straight line, there is a current, it is like a conductor, right. In this conductor, if there is any current flow in this conductor, and because of this current flow in this conductor, there will be a magnetic flux around this conductor that will be produced. So that is called Ampere's, that is a right hand thumb rule, that is a Ampere's law. So this is the rule. If you pass any current in the conductor, that produces some magnetic flux, right. So that is that can be understood by your right hand thumb. So if you keep this thumb like this, right, this straight line can be assumed as a conductor. When you pass the current through the conductor here, from here to here, what happens, this another other than the thumb, right, these fingers are, right, wrapped inside your hand, right. So that means that it is, this and all assumed as it is a magnetic flux, magnetic field. So this is Ampere's law or right hand thumb rule. So this must be understood for understanding the various concepts in the electronics. And so already we discussed the resistance, and the another thing is inductor and capacitor is there. So that we will see. First thing, that is a inductor.